So we're gonna start with the Lewis theory, right? One of the scientists who gave the theory why the atoms normally bond with each other. So what is Lewis theory? Lewis theory is given by the Lewis. It says emphasizes the importance of valence electron means, as I told you in the last previous chapter, that what are valence electron? Valence electron are those electrons that are orbiting in the last orbit of the atom, right? And that's the only electron that helps or take part in the reaction, right? So Lewis theory just emphasizes the importance of that valence electron, right? And then how the scientists or how you normally show the Lewis structure, right? Or Lewis symbol, you have to understand that thing. So according to Lewis, he uses a dot to represent valence electron either on or shared by the atom, right? What does it mean? You can make a Lewis symbol. Let's try to make some Lewis symbol of element. Okay. Let's say if I say I have a sodium element, Na, and I have to make a Lewis symbol according to the Lewis theory, right? That's called Lewis symbol, right? So Lewis symbol always contain the valence electron, right? The symbol of the element, and then you normally show the valence electron in the form of dot. So what's that dot mean? Dot is valence electron, right? So remember, people normally do the mistake whenever they make Lewis symbol, right? They are valence electron. So if I talk about sodium, sodium belongs to which group? Or I would say how many valence electrons sodium has? Sodium has just one valence electron because it belongs to the group 1, right? So how would you show the Lewis symbol of sodium? You have to just put one dot on sodium. So this is the Lewis symbol for sodium. Similarly, if I ask you for aluminium, how to draw the Lewis symbol? How many valence electron first you need to ask yourself for aluminium? Aluminium belongs to the third group in the periodic table and it has 3 valence electron. So how would you make a 3 dot? You have to make 3 dot, right? You always make sure you have to make a dot all across the element symbol first. So it doesn't matter whether you start going this way or you start going this way, making a dot doesn't matter, right? As long as you have 3 electron across aluminum, it's fine. But you cannot make them pair unless you move or make every electron across the element, right? So let's take an example for chlorine, Cl. How many valence electron chlorine has? It has 7 electron. So you have to do something like this: 1, 2, 3, 4. So you have to go all across the element first with each valence electron, right? And then if you're still left with something, then you have to get paired them up. So now you have 3 more electrons. So 1, 2, 3, 4, 5, 6, 7. So this is chlorine Lewis symbol, right? So like I already said, it doesn't matter. You can pair this electron, right? And leave this electron single, right? But it doesn't matter. So yeah. So this is how you normally make a Lewis symbol. So now let's get back to the slide. Right. So there's some example of the Lewis symbol over here, right? Like carbon, for example, over here at the bottom, carbon has 4 electron, 4 valence electron. That's why you can see you have 4 dot across carbon, right? Neon is a noble gas element. It has 8 valence electron. So you have 2 to 4 to 8, 6 and 8, right? So this is how you normally make a Lewis symbol. Once you will, so now we already learned how to make a Lewis symbol for any element or atom. Now we have to see what's Lewis bonding theory, right? How does this Lewis symbol helps to understand the bonding pattern between the element, right? Or atom. So it says atom bond because it results in a more stable electronic configurations, right? That's the ultimate aim for any element to bond with any other element, right? To get an stable configuration. If you remember, as like I said in the last previous chapter, that each element in the periodic table wants to be like noble gas element. Why? Because noble gas element has fully filled octet, right? Orbit. If the last orbit need 8 electron, it has 8 electron, right? But except noble gas element, none of the element has the fully filled orbit, the last orbit, right? So they need electron or they'll have to lose electron. So that's why. And how does this atom does this thing? By bonding with other element, right? Okay, so there are two ways that atom can bond with each other. One is either transferring the electron, second is by sharing the electron, right? So we'll go into in detail what is transferring and what is sharing, but make sure there are two ways, right, that we're gonna see in the upcoming slide. And then it's usually this result in an atom obtaining an outer shell with 8 electron, right? Like a noble gas element, they have 8 electron. And this is called octet rule, right? What is octet rule? Octet rule means the outermost orbit of any element should have 8 electron, right? The fully filled. They are stable, right? They don't need any extra electron. They don't want to lose any electron. They are like self-stabilized. So this is called a octet rule, right? But as usual, there are some exception to this octet rule, like lithium and beryllium. They try to achieve helium electronic configuration, means helium has just 2 valence electron on the last orbit, right? So there are some exception, but beside this, everyone else wants to be have 8 electron, especially period 2 elements. Okay, so like we learn how to write the Lewis symbol. Let me give you some example, some different example. Let's say we have sodium, right? Lewis symbol for sodium and A. So you have to put just one dot. This is sodium Lewis symbol, but what should be the Lewis symbol for sodium plus? Can I can I say the Lewis symbol for sodium plus is just Na? And then for, let's say, for chlorine, -1 was the Lewis symbol for this chlorine. So let's write chlorine. You have 7, 2, 3, 4, 5, 6, 7, and because of this -1 charge, you got one extra electron in the Lewis symbol, right? Because of this negative charge. And then how you have to just specify with a close bracket on both sides and then put -1 charge on the top. Why? Because when you count the number of valence electron across chlorine, you have 8 inside it, right? So this negative charge does just tell everyone that because of this negative charge, you have just one extra electron. So instead of 7, you have 8 electron for chlorine, right? Similarly for sodium, if you don't have any charge, then this is your Lewis symbol. If you have a charge, then you don't have any valence electron in that orbit, right? So you can make a Lewis symbol for any ions too, right? So yeah, so that will be it, right? So make sure you can make the Lewis symbol for any ions. Okay, so now let's get back to the slide. Right, so this is how it's done. Like they already done with fluorine too. If you have fluorine, you have 7 electron, but the time you put -1 charge on the top, you put one more extra electron, right? That makes that you have an extra electron. Okay, so now let's talk about there are, like I said, there are two ways that atoms can make a bond with any other atom. First, let's go over here. But first by sharing, and then other by transferring. Okay. So bond can be two type. First, by transferring electron, trans, So let me remove this one. By transferring, right, transferring, second by sharing, as such ARING, right, by sharing of electron, and this is electron, right? So we're going to see what is the name if you transfer the electron, if the transfer happened between the two atoms, and what's the name of the bond if you shared the electron. So if you transfer the electron, we call this kind of bond as ionic bond. Ionic bond, right? And if you remember from the previous chapter, we'd already discussed what are ionic bond. And if the atom shared the electron, then we call those kind of bond as covalent bond. Covalent bond. BO and D. Covalent bond, right? So ionic bond is formed between, if you remember, metal plus non-metal, right? Covalent bond is formed between non-metal and non-metal. Non-metal plus non-metal. Let me write NM. Non-metal plus non-metal, right? Let me write over here NM. So that you know, right? So, so we're gonna talk about separately what are ionic bond, right? And then what about covalent bond, right? By sharing of electron, but make sure you know the difference between transferring and sharing of electron, right? Okay. Let's get back to the slide. Okay. So now let's try to see how transferring of electron or ionic bond normally form, right? So let's take an example of calcium chloride. So if I give you a problem, let me give you on the whiteboard again. That will help you to understand. Okay. If I give you a two element, let's say calcium and chlorine. If I give you these two elements and then ask you which type of bond they can make, then how would you recognize that which kind of bond they're gonna make? So first you have to ask yourself, calcium is your metal, chlorine is your non-metal, right? Because it belongs to the seventh group, right? So once we know this is metal plus non-metal, whatever the compound they're gonna make an ionic compound, right? Second thing, if I ask you, show me which kind of compound they're gonna make using a Lewis symbol, then you have to show me the dot structure, right? So let's see that Lewis symbol. So for calcium, you have two dots because it belongs to the second group. Chlorine, you have seven dots, right? So how they're gonna make a compound? So chlorine is a non-metal. Each element wants to be a noble gas element, right? B means it has to have 8 electrons. So chlorine has 7 right now. It can ask calcium, okay, you have 2 extra, right? Nobody's going to give you 6 more to make it 8 over here. So the main thing is that if you can give me your 1 electron, then I will be a stable element, right? But calcium has to give up both of these 2 electrons. It cannot give just one, because if it just gives one, it's not stable. So both element has to get stable at the same time, or else bonding won't occur, right? Both has to be on the profit side. So what happened? Calcium says, okay, I can give you my one electron to your orbit, but I need to remove my second electron too, right? So the chlorine bring its friend, another chlorine, 2, 3, 4, 5, 6, 7. And now the second electron from the same calcium will be gone to the second element. Now this is over here. So what happened? Calcium donated both of its electron. Now I can say like this. Calcium has now +2 charge because it has donated both of the electron, and each chlorine now have 8 electron. And the time you put 8, you have to specify you have a -1 charge because each chlorine got 1 extra electron from calcium. Again, you have to specify -1 charge. Okay. So this is this is the way you have to show me if I ask you to show the Lewis structure of calcium chloride, right? You have to show calcium, which is a metal, has a positive charge, +2 in this case, and each non-metal, which is chlorine in this case, has both of them has -1 charge. So either you can write this way or you can write this way too. 2 of chlorine. So it's up to you. Put bracket on it and then -1 charge on the top. Means you have 1 calcium for every 2 chlorine, -1 charge. Right? So this is your calcium chloride. Right. So let me give you a homework. You have to show me the same thing. If you have any question, you can ask me the officer, right? Apply the same concept and then show me how you can make a compound between aluminium and chlorine, right? So you have to tell me what should be the compound molecular formula over here. Apply the same concept. The thing is that you can get as many as chlorine possible, right? So it's up to you. If I give you 1 chlorine, doesn't mean that you have to use just 1 chlorine like I did in this one. Before we have just 1 chlorine, but because of we have 1 extra electron on calcium, I just put 1 extra chlorine over here, right? So you can use as many chlorine as possible, but you have to make sure you cannot use more than like a required number of chlorine until you get rid of all the valence electron from aluminium, right? So make sure you try the compound between aluminium and chlorine, right, using a Lewis symbol. Okay, now let's get back to the slide. So we already done with the transferring of electron. Means for the ionic compound, let's talk about now covalent compound. Like I said, covalent compound are formed by shading of electron. What do you mean by the shading? So let me show you where the shading of electron. Let's get back to the whiteboard again, just to help you understand what is shading of electron. So like I said, for shading of electron, covalent bond and is formed between non-metal and non-metal. Right? Let's take an example. If you have 2 fluorine, if you have to make a bond between 2 fluorine, right? So first make using a Lewis structure or Lewis symbol. So let's make a Lewis symbol for fluorine. It has 7 electron, right? Because it belongs to the 7th group. This is 7, right? So now if both the fluorine is nearby, if one fluorine say, okay, can you give me your electron so that I can get stabilized? Other fluorine says, okay, I don't have enough electron, right? If you can give it to me instead of me giving you, I can also get stabilized, right? But there is no way is anyone can give the electron or transfer the electron. The only possible way is or the possible way that both of the element can benefit by sharing the electron. They share, okay, you can give one, I can give one, we can share, and then we both get stabilized. So means they share these two electrons, this electron and this electron. Now they are sharing. So what happened in sharing? Now this fluorine has how many electrons? 1, 2, 3, 4, 5. But we need one more. I forgot to put the sixth one. Okay. So you have 1, 2, 3, 4, 5, 6, 7, and then this is 8. So this fluorine is now stable with 8 electrons. And then what about the other fluorine again? 1, 2, 3, 4, 5, 6, 7, and 8. So this fluorine is also get stabilized with that 8 electron. Right? So this is how normally sharing happen when nobody wants to give the electron, right, to each other. And then they normally form a covalent bond, right? This is a covalent bond, which is a share. And if you see, to make a one single bond, how many electron each element has to share? One electron on both sides, right? This is electron, this is electron. So you have to just remember, to make a one single line of covalent bond, you need two electrons, right? And this is called as single bond, single covalent bond. Right. Similarly, we have single covalent, we have double and triple too. Right. Let's say some example for double and triple. Let me give for double, for oxygen. If we have oxygen, we have oxygen, two element of oxygen. So how are you going to make up both a non-metal, right? And then number of valence electron for oxygen is 6. So 1, 2, 3, 4, 5, 6, right? So they say to each other, okay, let's share the electron. If they share just one electron, how many electron each of them will have? 1, 2, 3, 4, 5, 6, and one for sharing from the other. It's not possible, right? Same apply for the other option. It will have 7 if they share just one electron. They say, okay, let's share one of our electron, right? Each of our electron. They share another electron. So now how many electron each option has? 1, 2, 3, 4, 5, 6, 7, 8. So this oxygen has 8 electrons. Similarly for the other element oxygen, they have 8 electrons. So now both of them are stable. So that's why for oxygen you have two bond, which is called double bond. And how many electron you need to make a double bond? 4 electron, or you can say 2 pair of electron. Each pair has 2 electron, right? So single, double, and then we have one last called triple bond. So let's take an example for that triple bond. Let's say nitrogen. Nitrogen belongs to which group? Fifth group. It has 5 valence electron. So let's put 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Right. And then how many electron they need to share with each other? They have 5, so they need 3. Each of them need 3, so they need to share 3 electrons from each side. So 1, 2, 3, right? And if you see, this nitrogen has 8 valence electron now because of sharing of the other 3, and the other one have 8 electron too, right? Both of them has 8, so they're stable. And this 3 bond we call as triple bond. Triple bond, right? So there are three kind of covalent bonds: single bond, double bond, and triple bond, right? Okay. So sometime you will see in the PowerPoint that the bond is normally show like this: 1, 2, 3, 1, 2, 3. You don't see any line between them in the PowerPoint, right? So that doesn't mean they're not making a bond. You will see just if you're seeing the electrons between the two element, right? Whatever the electron is placed between the two element, they are normally bonded. If you have 3 electron means 3 bond. If you have 2 electron like for oxygen between the two element, so they are get bonded even though you don't see a line, right? So make sure between the element they are bonded. Okay, so this is an important concept that you need to understand. Okay, and then let's get back to the slide. Right. So I already explained what are single bond, what are double bond, what are triple bond. You can read it out from the slide too, but it's the same concept that I explained you. So besides all the three type of bond, we have some more terms that you need to know. One is called bonding pair and one is called lone pair. So then we need to understand what is bond pair, lone pair. So so let's take the same example that you have on the PowerPoint over here. Right. So this is SO2 molecule, right? You have one sulfur and two oxygen, SO2. Right? So you have oxygen, sulfur, and oxygen. So how many bonds you have between this oxygen and this sulfur? The first two, you have a double bond, right? Because these two electrons are between sulfur and oxygen. Between the other, this sulfur and this oxygen, how many electron you have in there? Two. So even though they show it like this, up and down, it has same meaning that it has this way. So don't get confused, right? So two electron means one bond, single bond, right? So what are bonding pair of electron or bond pair of electron means the number of electrons they are taking part in making a bond. So in this molecule, how many bond pair over there? If you say pair, you have to count two electron as pair, right? Was one. So one pair, two pair, three pair. So in this molecule, you have three bond pair that making a bond. What is lone pair? Lone pair are those electrons pair that are present on the element but are not taking part in making a bond. So what are those in here? If you can see this electron, pair of electron, this pair of electron, they are over there but they are not making a bond with any other atom. They are just sitting there. The top electron pair on the sulfur, this is lone, not making any bond. And then this three on this oxygen because they are outside the bonding pattern, right? So how many lone pair you have in this molecule? 1, 2, 3, 4, 5, 6. So you have 6 lone pair, right? So 6 lone pair, or you can say 12 electrons. 3 bond pair means 6 electron, right? So make sure you read the question carefully whenever I ask you an exam and quiz. Bond pair or just bonding electron. They are two different terms. If I say bonding electrons, you have to write 6. If I say bonding pair or bond pair, you have to write 3 because I'm talking about pair. Right, so this is another important term that you need to remember. Okay, and then let's get back to the next slide here. So now let's talk about the multiplicity and bond property. So if I ask you, you have single bond, you have double bond, and you have triple bond. Which bond you think is the most strongest bond? The triple bond is the strongest bond, right? Strongest bond. Why? Because you have 3 pair of electron, 3 times more force of attraction compared to the one that has single bond, right? So higher the number of bond means more stronger is that bond. So that's called multiplicity. You have 3 bond, you have 2, and then this is single bond is a weaker bond compared to the 1, 2, and 3 bond. Right? Okay, and what do you think? Which one is the shortest bond in size or in length? Single bond, double bond, and triple bond. Which one is shortest in length? So triple bond is also a shortest in length. Why? Because of the 3 bond, the atoms across it, let's say A and B, they are pulling each other so strongly they're gonna get too close compared to the one that has just one single bond, right? So you can say triple bond is also a shortest bond, shortest, right? And the single bond is the longest bond, and double bond is in between, right? In between the longest and shortest bond. So you have to remember this small thing too for your multiple choice options. Which one is strongest, which one is the longest, shortest, right? Okay. So this is a thing that you can read it along. Okay, so till now we already learned about what a Lewis structure, right? How to write Lewis symbol, what are ionic compound, right? How you transfer, how atoms normally share electron, right? Everything. Now we have to use all those concepts and to build a molecule structure, right? If you have more than 3 atoms in a molecule, how are you going to draw that structure? Like HNO3, right? Nitric acid. So now we're gonna learn how to draw the structure using a Lewis symbol. Okay, so writing a Lewis structure for covalent molecule. So we're gonna start with the example, then you can read it by yourself on the PowerPoint, right? Everything is given, but I'm gonna start with the example to just show you how to solve the problem or how to draw the molecule. So we're gonna start with one of the molecule called HNO3. So let me show you how to draw it right on the whiteboard, then you can read it by yourself from the PowerPoint, right? Everything is all over there. So there are some steps that you need to follow. So let's start with HNO3, nitric acid. So you can write it down the time I'm saying, write on your notebook too, the steps, so that you can solve any molecule or draw any molecule using a Lewis symbol, right? Lewis structures. So the first step is calculate the number of valence electron in the molecule, right? So write it down this thing, calculate the number of total valence electron for the entire molecule. So hydrogen has how many valence electron? 1, right? Nitrogen has how many valence electron? It belongs to which group? What's the atomic number for nitrogen? So you have to go to the periodic table and then you have to ask, right? So if I say it has 5, then you have to look for your periodic table, right? Whether you understand why I'm writing this or not. And oxygen has how many valence electron? 6. And how many oxygen you have in here? 3. So you have to multiply each oxygen valence electron by 3 because you have 3 times. So total is 1, 5, because each of one has 1, 1. Oxygen has 3, 18. So what's the total number of valence electrons? 6, 18, 24. 24 valence electron. So this is your first step for every other molecule that you're going to try by yourself, right? Then make sure whatever the number of valence electron that you have to use all those electron to make this structure HNO3. You cannot use more than that. You cannot use less than that. You have to somehow use everything, whatever you calculated over here, right? Okay. Okay, so we have 24. So let's clear this one. Let be it here, right? The second step is to find it out which elements are more metallic except the hydrogen one. Whenever you have to pick how many atoms you have in this molecule, you have three different type of atom: hydrogen atom, nitrogen atom, oxygen atom. So whenever you have to pick the most metallic element, you don't need to consider hydrogen. Remove the hydrogen from your consideration, accept hydrogen, see how many different type of elements you have, and then compare. So now we have nitrogen and oxygen, right? So between nitrogen and oxygen, which one is more metallic? If you remember from the previous chapter that we talk about the trans metallic character. So if you remember, nitrogen is more metallic compared to oxygen. So this is your second step to figure it out which one is more metallic. The third one, once you figured out the metallic element, you have to pick the most metallic at the center and then put the second most metallic element across it. Oxygen, oxygen, oxygen. It doesn't matter whether you put it over here on the top, on the bottom, doesn't matter, right? So it's up to you. But you have to put three, but you don't have the fourth side, right? Because you're done with oxygen. Okay, now you're left with just hydrogen, right? The fourth step is you have to place the hydrogen from the ending, from the outermost atom. You cannot put hydrogen directly to the center atom. Make sure you don't do this thing because it's very easy to put hydrogen over here. So don't do this thing. Or hydrogen will always go to the corner atom, which is this oxygen, oxygen, oxygen. This is the center one, nitrogen. So don't put hydrogen over here, right? Okay. So the fourth one is always put hydrogen from the sides, from the corner. Okay. So now let's me put the hydrogen. So it doesn't matter which way you put. You can put over here, you can put over here, you can put on the third side, doesn't matter, right? So now we put every four element in there, right? Or the three. Then the next step, I would suggest make a bond, single bond between each of them, right? Because they cannot be separate because they need to have some bond, right? So that they can remain together. Okay, so the time you put four single bond, how many electron you use out of 24? So each bond, like I said, need 2 electron, right? 1 electron, 2. So if you put 4, that means you already use 8 electrons. Now you're left with 16 electron out of 24. Fine. Okay. Now you have to use 16 electron in this molecule and then try to make it, right? So the other step, you have to start putting or the electron from the outside. Don't directly put or start from the center and go outside. You always have to start from outside to inside, right? So let's start. Doesn't matter which end. You have three end: hydrogen end, oxygen end, and oxygen end. So let's start with that. Let's start with this hydrogen end, right? Is this hydrogen atom need any electron? So remember, for hydrogen, you just need 2 valence electron to get stabilized. You do not need 8 electron. You just need 2. Okay? So remember, for hydrogen, this is an exception. So how many electron this hydrogen has right now? It is already has 2 electron, one its own electron, and one by sharing with oxygen. So it has 2 electron, right? So we don't need to put any dot on this hydrogen. This is stable. Now let's move inward. Let's go from this side, the bottom oxygen. How many electron this oxygen has right now? It has 2 because it has just one bond, this bond. So it has 2 electron. How many it need more to make it 8? Because each element need 8 electron to fully fill its octet. So it needs 6 more. So let's put 6 dot. So now this oxygen is stable, 6 dot and 1 bond, 8 electron altogether. Let's go from the third side, right? This oxygen. Again, one single bond, how many electron you need? 6 more to make it 8, right? And then once you're done with all the outside atom, you have to go inside, right? You cannot go to the nitrogen because you have one inside oxygen too, right? You cannot go to the center one first. So how many electron we are left with? First calculate that thing. So you use 6 electron here, 6 electron here. So out of 16 you use 12. So now you are left with just 4 electron. So let's see how many electron this oxygen need, the center one over here between hydrogen and nitrogen. It has 2 bond, means it already has 4 electron, so it needs 4 more. So now this oxygen also have 8 electron, 1 2 3 4, and 2 coming from each bond, so total of 8 electron. So and then we use this 4 too. Now we done with all the 24, right? We already used it. So okay, let's do this one here. Okay. So now you have to, once you're done with all the 24 electron or whatever number of valence electron that you're using, now let's count. Each element has to have a fully filled octet, right? Full filled octet. Let's start with hydrogen. Hydrogen has full filled octet. Yes, it has 2 electrons, so this is good. This oxygen has 8 electron, 1 2 3 4 5 6 7 8. This oxygen is good. The bottom oxygen, 1 2 3 4 5 6 7 8. This oxygen is good, and the same for the fourth or third oxygen. This is good. Now let's talk about the center nitrogen atom. If it has 8 electron across it, this structure is good. If not, there's something wrong with the structure. So let's say how many you have. You have 1 2 3 3 bond. 3 bond means 3 pair of 3 bond is 6 electron. So there is a problem. Nitrogen has 6 electron here, and then this structure cannot be right because one of the element is not fully filled. So, and then we are done with all the 24 electrons. How are you gonna make this nitrogen as 8 electron? Now, if you can see, you have 3 oxygen across the nitrogen, and they are rich, right? They have lone pair. They are just sitting there without making a bond, right? So this oxygen, or the bottom oxygen, they can donate a pair of electron. So they say to nitrogen, okay, we are rich in electron. I can give you a pair of electron because you need one pair to make a bond. So they donate. And the time they donate, what's going to happen? Then you will get one bond here, right? And then you remove this 2 electron. You don't have anything over here, right? So now let's see, by donating this 2 electron, a pair of electron, does it affect this oxygen? Yes or no? Let's say if it has 8 electrons, then it's okay. So 1 2 3 4 and 2 bond 4 8. So this oxygen still has 8 electrons, so it doesn't affect this thing. But what happened? Because of this bond, nitrogen has 8 electron. 1 bond, 2 bond, 3 bond, 4 bond. 4 bond means 8 electron. Now this structure is good. So let me remove this one. So this is the right structure of HNO3, right, with a double bond with one of the oxygen. So this is how you normally make a loose structure or a molecule, right? So if you follow the same step like I told you right now, if you didn't see, you can just repeat the video, right? Replay the video and see how you normally do this molecule, right? And then try to make as many molecules as possible as practice, right? Okay, let's back to the slide here. So everything is explained in the slide too, right? How I did. So it's up to you whether you learn from the video or you can read it exact. They have exactly the same information, right? And then sometimes we have to draw the loose structure for polyatomic ion. If you remember from the previous chapter, what is polyatomic ion, right? They are more when more than 2 atoms combine together, right? they form a polyatom. So one of the example is NO3 negative. Right, so let's try to do this example over here. So let me do it fast, and then you can see whether I'm doing the same way like I told you for the HNO3, right? So you have NO3 negative. So first step is calculate the total number of valence electron. So nitrogen has 5 valence electron, oxygen has 6, and how many oxygen you have? 3. So this is total 5, this is 18, so total is 23 valence electron for NO3. But what you have here, you have a negative sign. So because what is my negative sign, you have one extra electron. So total is 24 again. You have 24 electron. Right, so make sure you always add an electron or 2 electron depending on the charge. Right, if you would have, let's say for example, if you would have a positive charge, you would have taken 1 electron from the total, because positive means it lost, right? Negative means it gained, right? So again the same thing, nitrogen at the center, most metallic element, oxygen on the side, make a single bond. The time you make a single bond, you use 6 electron. Now you're left with 18 electron that you have to follow. So let's start from the corners. You have 3 corner, 3 oxygen atom. Put 2. It needs 6. It also needs 6. And this oxygen also need 6. Let's see how many electron we used. 6 over here, 6 lone pair, 3 lone pair, 3 lone pair, 3 lone pair. Total is 18. And now you have 3 bond, 1, 2, 3. 18 plus 6, 24. We already used 24 electron. But nitrogen is not balanced. Nitrogen has 1, 2, 3, 6 electron. It needs 2 more. So it doesn't matter whether this electron or this oxygen or this oxygen. Any oxygen can donate. So let's donate the same way from here. It's okay, I can donate your a pair and you can make a bond. And now this electron is gone. Right, let me remove this electron. Right. Then this is the right structure for your NO3. Right. And the time you make this NO3, always close in a bracket. Why? Because you have to specify this negative charge on the top. Right. So this is the structure of NO3 negative. Exactly the same step that I followed in the previous example. You solve this one. So yeah, just practice as much as possible. Okay. So now let's get to the slide again. So everything is explained in the PowerPoint too, then you can see it, right? And then you have some example for practice, how to make the molecule using the same steps. So I would recommend take the molecule, draw it by yourself, and then try to see the answer over here with how many total valence electron and how they made a structure. So don't see the answer right away, right? That will help you to practice more, right? Okay, so make sure you practice all this example. Right. Okay, so I would say one thing over here. For example, H3BO3 boron. So don't worry, boron doesn't have weight, right? This is an exception, right? So don't worry, because this structure has just 6 electron across boron, 3 bond, right? So don't worry about it. This is an exception. I won't give you any exception in the exam or quiz. I'll just give you those molecule which has 8 electron, right? The octet rules, which follow octet rule. But except that, boron S3BO3, everything is good. So practice as much as possible.